What I thought what would be interesting to discuss with the superposition principle is to also show some small example. And yeah, let's do it with some linear network of two resistors. So I will once again copy this and put it into my drawing program here, opening up a new node and pasting this. And what I would once again like to do now is to compare it with a small measurement. And so for the small measurement, I've brought my multimeter and I will switch it on at first to measure voltages. And I have two batteries. And at first we can measure the voltage of these batteries individually. So the first battery, I have, as you can see, not for a long time not recharged them, but this is 1.305 volts. And the second battery, so this is the first one, and the second one has a little less, has 1.193 volts. Okay. And with these two sources, I would like to power two resistors. And so here I have two resistors. These should be all resistors with a color code of brown. It's difficult to see in the camera. Brown, black, and red. And brown is 10. Black is another 0, and red is also another 0. And so we get 1000 ohm or 1 kilo ohm. And there you can see, so the first resistor is 0.998 kilo ohm. And this is what I will build into the circuit here at this position. And then we have a second resistor that just fell down somewhere. Oh, luckily I have more resistors. So I will try to find this one later. And this one has 1.001 kilo ohm. Okay, so I will connect them both in series. And so now the idea is, if we take the first source and just connect the first source, you can approximately calculate in your head what we should get. We have two 1 kilo ohm resistances. If we just measure the voltage here across one of these resistors, and if we now power this, oh no, this was not my first voltage source, this was the second voltage source, but it does not matter. So now we power it with this second voltage source. What voltage should we get here approximately? Yeah, half of it. So a little less than 0.6. So if I go to voltage measurement back, and if I connect this here at the second resistor, so we get a little less than 0.6. So V2 powered by the second source is 0.596 volt. This is what we have there. Okay. So I disconnect the second source. I just connect the first source. And once again, which voltage should I get if I measure? Half of this, 0.65, something like this. So let's measure. And then we get 0.653 volts. So V1, V2 from the first source is 0.653 volt. Okay, so now if I connect both sources in series, what should I get?
The median, like the middle of the two sources?
Yeah, but if I connect them really in series, so now, so this is the individual. So now we do superposition.
The sum of those two values.
Exactly. We should get the sum of the two. So V2 should be the V2 from the first source plus the V2 from the second source. And 6 and 3 are 9. 5 and 9 are 14. And so then we get 1.249 volts, if I calculate this correctly. And so let's check if this fits. So this is the first source connected. Now I connect the second source. And I once again measure the voltage across this resistor. And so what we measure then, as you can see, nicely fits to what we calculated before. So in this circuit, if you do superposition in a measurement in this linear circuit, we just take the influence of the first source, just take the influence of the second source, sum them up, then really connect both sources, get the very same result. Perfectly works fine. Okay, so then we can continue with the second experiment. So here are my slides. And this was the linear network. So let's go to a nonlinear network. And what would you expect in this case if we build this nonlinear network? We have the same two sources as before. We have the same resistor as before, but instead of the second resistor, we use a diode. So what have we discussed before? It should not work, right? Now we should get something strange, something that does not fit. So let's try it out. I will copy this once again and maybe paste it here into the same page and just put the camera window to the other side. So we have the same sources as before, we have the same resistance as before. Now we should get different values for V21 and V22, and now we can do a different superposition and get a V2 in total. So let's check. And I will remove my multimeter for a second so that the camera can focus on the circuit. I will remove the sources once again. So this is the first source, this is the second source. And instead of the resistor, this was the second resistor, I will now connect a diode. So there's a small diode, and maybe I can try to enlarge the camera view here for a second. So it's difficult to see, but the diode You can barely see it. On one side, on the left side, there is some ring, there is some black ring, and this is the cathode of the diode. So this is where the current flows out of the diode. So I need to connect it like this, and then it should be the same way as in my, no, it's not the same way as in my circuit, right? Because my circuit looks like this, and so yeah, no, it's the cathode is at the bottom. Perfectly makes sense. So this is now how the circuit looks like. So let's make the camera window once again a little smaller. And connect the first source. This was the first source. So I will connect the first source to our circuit. And with the multimeter, here's the multimeter back again, measure the voltage drop across the diode. So, and we can see, okay, as before, we get something like 0.598 volts. 0.598 volts. Okay, this was the result when the first source is connected. So now I can connect disconnect the first source. This is the first source. Connect the second source. So connect it here. Connect it into this row. So now the second source is connected, and I need to connect the multimeter back again. And so now for the second source, we also get something like 0.590 volts. Yeah, and so remember here, so in comparison with what we had before, now this is interchanged here. That's why here the first one was a little less, or the first value was a little less, but this was for the second source, and so here this is also a little less than this. It's just written down in the different order. So if we do superposition, and if we would calculate the sum of the two, what we would get is 8 and 0 is 8, 9 and 9 is 18, and 1 and 1, 5 and 5 is 10, and another 1 is 11. So we should get 1.188 volts, right? This is the sum of the two. Okay, so let's go back to the measurement. Let's disconnect the multimeter. And this is the second source that is now connected. And if I also connect the first source to our circuit, so now both sources are connected, and I once again also connect the multimeter. So then we get something completely different, namely 0.643 volt. So V2 measured is something completely different, right? When we did here the measurement, it was 1.248 if I remember correctly. So here it fits because it's a linear network. Here it doesn't fit because it's a nonlinear network. And then, so in this case, you cannot use superposition. It just won't work. And this is what we've also shown here in this small experiment.